So let's take some question over here. Okay, so a stock can either increase or decrease, okay, in a day. The probability of increasing is 0.6 and decreasing is 0.4. Okay, the probability remains the same. The probability remains same, okay, throughout. Okay. Find the probability that stock will increase, the stock price will increase for 4 days. Find the probability that the stock price will increase for 4 days out of 7 days. So in 7 days, what is the probability that the stock will increase for 4 days? Okay. Now, also, like there is a term called as credit default swap. Okay. So in credit default swap, what you have is like you have a basket. Okay. So you have a basket wherein you keep bonds. Okay. So in this credit default swap, you have like, let's say 5 bonds are kept. So in this credit default basket, you have 5 bonds are kept, and you have like what will happen is you say that whenever one bond will default, so you say that whenever one bond default, this CDS goes bust. Okay, so whenever one bond default, this CDS goes bust. Okay, now what we are interested in knowing, so you have these 5 bonds, the probability of default, the probability of default of each bond is, let's say, 0.05. The probability that each bond will default is 0.05. Okay, I want to know the probability that exactly one bond will default. So out of 5 bonds, what is the probability that exactly one bond will default? So you have 2 questions. The first question answer is Beneath has given 0.29. Second question, Beneath has given 0.20. Okay. Okay. Let's try to, the first one seems to be pretty easy. What you have is you have 7 days. Out of 7 days, the stock will increase for 4 days. In each day, the probability of the stock increasing is 0.6. For 4 days, it will be 0.6 to the power 4, and here it will be 0.4 to the power 3. So this is the probability that the stock will increase for 4 days. Okay. Now, what happens is when you have this credit default swap basket, the probability of default of each bond is 0.05. Okay. Now this will go bust when one bond default. Okay. So when one bond default, it will go bust. So I want to know what is the probability of it going bust. Okay. By when it is one bond defaulting. So the first bond default. So this default basket, it is called as first to default. Okay. First to default means any bond default, first the basket will go bust. Okay, so exactly one bond will default. What is the probability? So here you have 5 bonds, right? Out of these 5 bonds, you will have one bond which will be defaulting. So can I say that out of these 5, any bond can default? So out of the 5, any one can default. So I have to select any one. Okay, what is the probability of that bond defaulting? 0.05. So you have 0.05 to the power 1, right? The bond which is defaulting, it has a probability of this. When this one bond is defaulting, we have said that exactly one bond will default. It means that 4 bonds are not defaulting, right? So you have, when 4 bonds are not defaulting, what is the probability that 4 bond will not default? Can I say it will be 0.95 to the power 4? So what we have is 5C1 0.05 into 0.95 to the power 4. So if you compute, 5C1 will give you value 5 into 0.05 into 0.95, okay, to the power 4, you can get square square, so it will be equal to, so the answer comes as 0.203626. So the probability of exactly one bond defaulting will be 0.203. Okay, this probability will be 7C4 is given as 7C4 will be 7 into 6 into 5 divided by 6. So 7 into 5, 35. So that is 35 into 0.4 whole cube into 0.6 square square. So the first answer also you guys have got correctly. So the first answer is 0.29, the second answer is 0.20. Okay. Okay. So this is an example of a binomial distribution. So please note that in a binomial distribution you have either of the thing is happening. Okay. So that means success or failure. Okay. So that is what you had in the binomial distribution. Another questions you can take in case of the binomial. Okay, there's a bond. There's a bond. It will mature in 4 years. Okay, the probability of the bond defaulting in year 1 is given as. The probability of the bond defaulting in year 1 is given as 10%. Year 2 is given as 8%. Year 3 is 5%. Year 4 is 3%. Okay, so these are the probability that the bond will default. Now the question is, what is the cumulative probability? What is the cumulative probability that the bond will default by year 4? Okay, by year 4, I am interested in finding out that the bond would default. Okay, so there is like one long way to do this, and there is one short way to do this. Okay, but like you need to get an understanding of how to find. Okay, so you have a bond. Okay, so think about a tree diagram for this bond. What happens is you are starting at t equal to 0, bond will default. Okay, this probability is given as 0.1. Bond is not defaulting. This is given as 0.9, and then again it defaults. This is given as 0.08. Then again it is not defaulting. This probability is given as 0.92, then bond defaults, it is given as 0.05. The same way we had done earlier, this is 0.95, this is 0.03, this is 0.97. So here I want to find out the cumulative probability that the bond has defaulted. So bond has defaulted here, D, 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 D. This is a case the bond has not defaulted. So I want to know the cumulative probability that the bond has defaulted in by year 4. I am not asking for year 4. Okay, by year 4, that means first year, second year, third year, fourth year. It is cumulative. I want to know that. So there are like two approaches. The long approach, let's see what is the probability of default in the first year. So I can say that the probability of default over all the 4 years is default in the first year plus default in the second year plus third year plus fourth year. What is the probability of default in the second year? Can I say 0.72? Not defaulting into defaulting. So that is the probability of default. So it will be 0.9 into 0.08 plus you have the probability 0.9 into 0.92 into 0.05 is the probability of default in the third year. So 0.9 into 0.92 into 0.05 plus you have the probability of default in the fourth year will be 0.9 into 92 into 95 into 0.03. So this would give you a long way to answer. The short way would be, can I say that this D1, D2, D3, D4, D1 plus D2 plus D3 plus D4 plus not defaulting will be equal to 1. Can I say that? Now if I want to find out this, they can be said as 1 minus probability of not defaulting. What is the probability of not defaulting? Can I say the probability of not defaulting will be equal to not defaulting in first year, not defaulting in second year, not defaulting in third year, and not defaulting in fourth year. So if you compute that, it will be 0.9 into 0.92 into 0.95 into, sorry, so you have 0.9 into 0.92 into 0.95 into 0.97. So that is the probability of not defaulting -1. Okay, so you have the answer will be 0.2369 or 0.237. So that is the answer. So like you can use, this is not a case of binomial distribution by the way, but what I said is like you had probability of success, probability of failure, and here you had different probability of success and failure. So when you have different probability of success and failure, you cannot directly use the binomial distribution. Okay. The third type of distribution which you will have over here, it is known as Poisson distribution. Okay. Now Poisson distribution is a discrete distribution, okay, and it is used to model the, it is used to find out the probability, okay, for a certain period of time. What you are getting is you are getting 200 calls on an average in 1 day, 1 hour. 200 calls on an average in 1 hour. Okay, I want to know the probability, okay, that I will be able to get, okay, what is the probability that I will be able to get, let's say 100 calls in 1 hour. So think about it, what I am saying. I am saying that 200 calls you will get in 1 hour, that is on an average. On an average you are getting 200 calls in 1 hour. Okay, but it does not mean that every day you will, every hour you will get 200 calls, right? Some hour you can get 50, some hour you can get 100, some hour you can get 1000. I want to know what is the probability that you will get 100 calls in 1 hour. Okay, and that probability is following, this follows what is known as Poisson distribution. Okay, the probability of that is given as the probability that x will be equal to k, okay, wherein k over here is 100 calls, is given as lambda to the power k divided by k factorial, okay, e to the power minus lambda. Now what is this lambda? Lambda is the average number of calls. So a lambda is the average number of calls that you are getting. Okay. So lambda is the average number of calls that you are getting. Okay. K is what I want. Okay. K is what I want for a particular day. Okay, and so let us try to make this slightly simple, because k factorial you will not be able to compute. Let's say you are able to get 240 calls. The number of calls, you will get 240 calls in 1 hour. Okay, what is the probability that you will get, okay, let's say 2 calls in 1 minute? You are getting 240 calls in 1 hour. So how many calls you are getting on an average in a minute? In 1 minute you are getting 4 calls. Okay, I want to know what is the probability that you will get 2 calls in 1 minute. Okay, now what over here is, we are saying that the probability that I will get 2 calls in a minute would be given as how much on an average I am getting. Lambda is on an average I am getting. So for the Poisson distribution, the mean is given as lambda. The mean is given by lambda. So for Poisson distribution, mean is given by lambda. So what is the probability that you will get 2 calls? It is given as lambda mean 4 square e to the power minus 4 divided by 2 factorial. So that is the answer. Okay, so if you compute this, okay, it will come as some value. Okay, So e to the power minus 4, 4 square to the power 2 factorial. Okay. Now I may ask you question. So let's take this. Okay. So you have lambda is 4. Okay. So lambda is 4 calls per minute. I want to know the probability that you get 1 call, 2 call, 3 call, 4 call, 5 call, 6 call. The number of calls you are getting is this. So for this 1 call, what we can write is, for 1 call we have lambda. So the probability x equal to k is given as lambda to the power k to k factorial e to the power minus lambda. So this is how you have the formula. Okay. Now for 1 call it will be how much? Lambda divided by 1 factorial. So for first call it will be e to the power minus lambda. Okay. Second call it will be lambda square e to the power minus lambda divided by 2 factorial. Okay. So this is 4 e to the power minus 4. This is, you have computed, this is 4 square 16, 8 e to the power minus 4. So this is 4 e to the power minus 4, this is 8 e to the power minus 4. It has increased 2 times. Okay. The probability that the number of 3 calls will happen is lambda to the power 3, okay, e to the power minus lambda by 3 factorial. If you compute this, lambda 4 cube by 3 factorial is 6 e to the power minus 4. This is how much? 4, 6. So you will be getting 16 e to the power minus 4. Okay. You have 2 by 3. So you have 2 by 3 into 16. So this is still, I can say how much? Roughly 10.67 e to the power minus 4. Again it has increased. It has increased from the previous case. What about the 4 call? Lambda to the power 4, 4 factorial e to the power minus lambda. Okay, so you have 4 to the power 4 divided by 4 factorial. Okay, I can write 4 factorial as 3 factorial, 4 into 3 factorial e to the power minus 4. Okay, so this can be written as 4 cube to the power 3 factorial e to the power minus 4. Okay, which is same as this. If you compute 4 cube by 4 to the power 4 by 4 factorial, 4, this 4 will get cancelled off. This and this is the same. Okay. For 5 call, if you want, it will become 4 to the power 5 e to the power minus lambda. It will become 5 factorial. Okay. Or it can be written as 4 by 4 into 4 to the power 4 e to the power minus 4. This 5 factorial we can write as 5 into 4 factorial. Now this is what? Can we say this is this 4 call? So 4 by 5 or 0.8 into the probability of 4 calls. Okay. If you see this 6, it will be 4 to the power 6 into e to the power minus lambda by 6 factorial. So e to the power minus 0.4. Okay. Now what happens is, this you can see as 4 by 6 into your 4 to the power 5 e to the power minus 4 by 5 factorial. So you can say as 0.67 into the probability of 5 call. Okay. So what is happening is, initially the probability was lesser, right? It was increasing. So 2 times it increased. Okay. Again it increased. It remained constant. It decreased. It started decreasing. So typically the Poisson distribution, what you see is, okay, initially that it is lower. So for x equal to 1, it is lower. Okay, it increases. Okay, it increases. Okay, again it may increase. Okay, then it start going down. Okay, now this depends on your lambda. Okay, this depends on your lambda. Okay, and how many numbers you want over here. Okay, so it depends on your mean. Okay, now you have, this is a distribution. If you have, like over here we have done only for 6. Okay, if you do it for more, you will be seeing a kind of a more distribution. It might take a form of your, like similar to your normal distribution. Okay, so this is a discrete. Okay, this is a discrete distribution. Okay, if you increase the number, and if you make it, or k if you make it more, if you k make it infinite, what will happen is this is infinite, this is infinite. Okay, so you will be like seeing a different kind of distribution. Okay, now there is a relationship between a binomial distribution, okay, between a binomial distribution and a Poisson distribution. Okay, you can make binomial distribution a Poisson distribution. Okay, for that, what you need to have is the number of trials in a binomial distribution. You make it very large. The number of trials, if you make it very large, it will become a Poisson distribution. So what you have was NCR p to the power r q to the power n minus r. Okay, if you make n very large, okay, n you make it very high number of trials, the binomial distribution tends to become a Poisson distribution. So it will become your lambda to the power k, k factorial, k, and e to the power minus lambda. It will roughly become this. So here you have k as this. Okay, it will become roughly this. Okay, with lambda is equal to the mean as equal to n into p. So for a binomial distribution, I did not cover that. Okay, for a Bernoulli, we know that the mean is how much? P, and variance is p into q. For a binomial, the mean is np and the variance is given as np into q. Okay, so this is for Bernoulli, this is for binomial. For a Poisson distribution, the mean is given as lambda. The mean is given as lambda, and one important thing over here in Poisson distribution is that the variance of the distribution is also lambda. So mean and the variance of a Poisson distribution are both lambda. Okay, so please remember this. Okay, Bernoulli, binomial, Poisson. Okay, you have to know the mean, you have to know the variance. P, NP, lambda, lambda, NPQ, PQ. A binomial distribution will become a normal distribution when n becomes infinite. Okay, and n is very large. Okay, so it will become a, so you can say that for very large, lambda will become NP. Many times, like people say that normal distribution can also approximate the Poisson distribution. Okay, now a normal distribution, so that is like we will cover it in the next class, but a normal distribution will become a Poisson distribution, okay, or a Poisson distribution for that matter will become a normal distribution when your lambda is large, when the mean is large, okay, and the probability of success is very close to 1. Then it will become, okay, it will become a normal distribution. Okay, but for your benefit, what I would say is, like, you have to remember the Poisson distribution formula. Probability that x is equal to k is given as lambda k, k factorial e to the power minus lambda. Okay, because in the previous exams they have asked questions around this. Okay, so let's say there is a question, okay, in a factory. Okay, in a factory, okay, there is a fire alarm. Okay, there is a fire alarm, and what happens is this fire alarm is erratic. Okay, it raises false alarm. So the fire alarm, it raises a false alarm. Okay, and in one day you get 5 false alarm. Okay, in one day you get 5 false alarm. Okay, you want to know what is the probability that you will get 2 false alarm in one day. The question makes sense. So the 5 fire alarm in one day on an average we get. On an average we get 5 false alarm. I want to know what is the probability that in one particular day we will get 2 false alarm. Okay. So here you need to identify what are K, what is lambda. Okay. What is lambda? So what you have is lambda is how much? Lambda is always the mean 5. What is the K? K is 2. So we are interested in this. So the probability will be given as lambda square 5 square divided by 5 factorial e to the power minus 5. Okay, so this is how you will compute. So this will be 5 by 24 and then you have to compute the e to the power minus 5. Okay, so if I want, I do not know how to compute e over here. Okay, let's say 2.72 x to the power y 5 minus equal to into 5 by. Okay, I'm getting very wrong and less answer. I think you guys are correct. Okay, 0.083. 0.083. I think most of the people are getting 0.083. I do not know how I am getting this. Okay. So it should be 5 square 2. So 25 by 2 into e to the power minus 5. Okay. So this is one problem like that you can get in an examination wherein like they are asking for computation of the probability. Okay. So this completes your discrete distribution. So if you see over here the aim statement, okay, what they are asking us to properties, okay, binomial Poisson, okay, identify distribution function of binomial for various parameter values. So what I would do is like I will send you the chart. Okay, so for different values of lambda, what are the different the shape. So when lambda is 1, it typically becomes like a normal. When lambda is very high, what happens when the lambda is such on the net? I will send you the graphs for the various parameter values. Okay, so this is a simple chapter, but this is your complex chapter. Okay, so we'll be seeing in the next class, okay, the continuous probability distribution.